Click. Okay. The clicker's not working. It's not good. I don't know why it's not working. All right. Gonna have to go to manual. We're going to start talking about how to take a derivative. Now, let's back up. That whole limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x is actually the derivative. But if we had to do that over and over again every time we have to take a derivative, we'd go insane. So we're going to start finding some shortcuts to make our lives a lot easier. Because you're going to take a lot of derivatives. The clicker's not working. This not. All right, I'm going to give it out. Okay. So, you should be able to find the derivative using the constant rule. Okay, so let's think about that for a second. A constant rule. A constant is a number, yes? So if we have a function. Oh, wait a second, I might be in business. This is going to be great. Oh, I know what I did wrong. It works better when you put the thingamabob in there. Nobody cares. Oh, beautiful. Okay, so constant rule is a number. What's the graph of a number look like?
Horizontal.
Horizontal line, correct. Okay. So we'll talk about how to find that derivative. It's pretty easy. We'll get there. We're going to learn the power rule. This is probably the single most common thing you'll do in this entire class. You're going to do this so much, you're going to want to scream. But it's going to become second nature through practice, where by the time we get to May, you're not even going to have to think about it. We're going to talk about the constant multiple rule. What happens if you take a function and multiply it by a constant? How do you take the derivative of that? So we're going to talk about how to find the derivative of x squared, but what if I throw a 3 in front of that? How do I take the derivative of 3x squared? Then we're going to talk about sums and differences, adding and subtracting. And then we're going to come back to our friend E. Anybody want to take a shot at E? Anybody remember? Anyone? Bueller? Anyone? Liam? Don't hurt yourself. You got this. Come on, eyes on the prize. All 20 numbers. You know you're bringing your own cheerleader with you. What do you got?
I don't remember.
2 is a good start.
2.1.
No.
No. 2.7.
Which president was he?
2.718.
Anybody else? What year did he win the election?
26.
No, close. 1828. Ran for 2 terms.
1828, 28.
And then the triangle.
90, 45, 90.
45,
45,
90, 45. Yeah, but same idea. Okay, good. That's completely irrelevant, but we'll get to that eventually. Okay, so here we go. Horizontal line, as Posey informed us earlier, commonly use the letter C to represent a constant. So what happens when you take that derivative? Remember, when we did the difference quotient, the derivative is defined as the slope of the tangent line. So without the limit in front of it, the difference quotient, that f of x plus delta x minus f of x all over delta x, is the slope of the secant line. When we take the limit, we get the slope of the tangent line. So therefore, what would be the slope of a, sorry, wrong question. What would be the derivative of a constant?
0.
Good, because the slope of the horizontal line is?
0.
0, beautiful. Ooh, new notation. This is exciting. dy dx means, I know it just says d dx there, but hold on. Hold, please. Pen, red. dy dx is one person's notation, and I'll talk about the other person also. That means what is the derivative of y with respect to the variable x. Okay, let me say that again. What is the derivative of y, the function y, with respect to the variable x? For the most part, we will use dy dx over and over again, but occasionally we might look at something like this. What does that mean? How's that?
When it's still be just, well, it's tea time, or is
It could, t could be anything.
It's whatever,
Probably is going to be time.
It's whatever you define it as.
Good. And what's the function called? What's the function here? What are we taking the derivative of?
X or Y.
Y. What's the derivative here? Z. Good. Take the derivative of z with respect to the variable t. Okay? And that will change a lot. At some point, we're going to get to something called related rates problems. Related rates problems are word problems that involve things like being up on a ladder and the bottom of the ladder starts to slide out. How fast are you going to come crashing to the ground? Two cars are heading towards the same intersection. One's doing 60, the other one's doing 70. How long till they crash into each other? Those kinds of questions. Most of them involve death and destruction, but we'll get to that later. So we need to understand this notation. Okay? So what it says here then is, what is the derivative of the constant c with respect to x? And I think we've beaten this into the ground already. It's 0 because it's a horizontal line, and the horizontal line has a slope of 0. Beautiful. There it is in a rectangle with curved edges, so it must be important. We're good? Excellent. So we just start looking at some examples then. What is the derivative of 7? 0. And this is going to become very repetitive, but I'm just trying to make a point. What's the derivative of 0? Oh, wait, new notation. Okay, now we got this bad boy. That's read as f prime of x. So why do we have two different notations? Quick history lesson, kids. You've heard of the guy Isaac Newton, yes? Tell me about Newton. What did he do? What'd you say? Yeah, laws of motion. Physics guy. Complete and utter jerk. Did your physics teachers tell you that? No, they won't, because physics teachers love Newton. They think he's great. Us math guys, they realized Newton was a complete jerk. While Newton was discovering calculus, or creating calculus, another guy named Leibniz was doing the same thing, which is kind of freaky. What are the chances of two guys at about the same time coming up with the same ideas? Well, they did. They used different notation, however. Newton liked the dy over dx thing, derivative of y with respect to x. Leibniz liked function notation, f prime of x. What is the derivative of f with respect to x? You're going to have to get comfortable bouncing back and forth between both of them. Why was Newton a jerk, by the way? Sidebar. Newton found out about Leibniz's discoveries, couldn't handle it, so he got all his little nerdy physics and math friends together and basically made Leibniz's life a living hell. He died broke, alone, poor, sad. And Newton went on to be the guy that didn't have the math. This doesn't seem right. Let's move on. Derivative of -3. Okay, now my function is s. My variable is t. S prime of t, what is the derivative of the function s with respect to t? Still going to be 0. Last but not least, what is the derivative of pi squared? Remember, pi is a number, just like e is a number. And the derivative of any number is still going to be 0. Now in number 4, I got a little fancies in my pantsies, and instead of switching to dy dx, I left it with y, but then I used Leibniz's notation to say y prime. We can flip back and forth between the two. Okay, so it's the same thing over and over again. Trying to make it clear that anytime you have a constant, the derivative is going to be 0. And the reason I'm making a big deal about it is because at some point you will forget it. And if you forget it, it's going to create a big, ugly, scary calculation that you do, and then you get to the end and you're like, oh, yeah, that part is just 0. So I'm trying to help you not do that. Now the big one. This is huge. Okay? We want to be able to take the derivative of any polynomial. So we're going to start small. We're going to take x to the something. That something is n. How many of you have done this before in physics? Uno?
In AP physics, which is what checklist is for.
Maybe physics.
AP advanced placement, that's what they say.
This
Or
one.
all-purpose.
Taking that.
Flour, all-purpose.
Yeah,
Well, how did he have a different experience? Oh, okay, well, anyway, let's move on, shall we? It's good. Most of you have not done this before, but it's real simple. In English, I don't know if I wrote it in English. Oh, I did do that? Oh, hey, how important is this? I'll show you. It's that important. Yeah, it gets bigger and turns blue.
Whoa.
Yeah. I didn't even think of that, Abby. What if this lesson had happened on Thursday then? Okay, that's great. I wish I could say I planned that. I did not. It's a fluke. But yeah, I planned this. Big Blue Friday, you know. In English, it's real simple. Bring the exponent out in front, reduce it by 1. That's it. Okay. Wouldn't it be nice if it was that simple? But you know what? There's no catch here. It's just that simple. Let's try some examples, shall we? What's the derivative of x cubed, Nathan?
3x to the second.
Well done. Good start. We're off and running. Parts Bay. What's the derivative of the cubic root of x? Mia!
You said Mia.
I did. I'm sorry.
Isn't it 1/3 x times
Oh, keep
negative
going. Come on. You're almost there.
to the negative 1/3 power? 2/3 power.
Or as Grandpa Selmer would say, 2 turds.
Oh, yeah.
Outstanding. However, we don't want negative exponents. So we're going to do baby steps here. Initially, if you want to leave it in terms of a negative exponent, then go ahead. Eventually, however, we're going to get rid of negative exponents. That in itself is going to take a little bit of practice. I'm happy if you can get to 1/3 x to the negative 2/3. Okay, how are we doing? What do we got? Huh? What? You want to fight when? Huh? Now? I just said when. You want to fight when?
3:30.
3:30 by the bike rack?
Yeah.
All right, I'll be there. You bringing friends? Should I bring friends?
Yes.
How many?
One.
Just one friend? Somebody hold your backpack? Okay, got it. Answer? Because she's talking smack. I'm not going to take it from her.
Negative 1/2.
That's a divided by? No. Well, Liam?
1/2x?
1/2x is incorrect.
Negative 2 times 1 over x cubed? No. Cube? No.
I don't know.
Cube?
Are you asking a question or telling us the answer?
Yeah, that's the answer.
Maeve, do you agree?
No?
No, your name's not Maeve. This is Maeve. You're Liam.
Yeah.
Yes, your name is Maeve, or yes, you agree, or both?
Yes, I-
Yes to
both.
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 Got you. Okay, there you go.
Yeah, you told me it was wrong.
No, you didn't have the minus, did you?
Yes, I did.
I'm sorry. Look, give me a break. It kind of looks like it's an
Yeah,
equal sign. Okay, it's Friday. Leave me alone. God.
You were like, no. I'm like, oh.
No! That's exactly how I answered. I hate this class. Can I drop? When's the drop date?
It will be asked.
Does anybody know?
It's
It's passed?
I was supposed to.
Fine. Now, you'll notice in part C, that's actually a quotient, yes? That's 1 divided by x squared. Later on, Wednesday, I'll show you how to take the derivative of a quotient, but it's ugly. We don't want to do that. In this case, you'll notice I just simply wrote it as x to the negative 2, and I'm good to go. What if that wasn't a 1? What if that 1 was an 8?
X to the negative 2.
Good, it would just be 8x to the negative 2. Write it that way, take the derivative, bingo, good to go. Okay, so this is pretty simple. Go back to this very quickly. What if there's a number in front of the function? What if instead of 3x cubed, what if instead of x cubed it was 3x cubed? What would you do with that number out in front? Bingo. It's the constant multiple rule. Multiply it by a constant. There it is, in fancy schmancy maroon rectangles. So it's got to be a big deal. Not going to turn blue this time. Now you might be saying to yourself, okay, so I move the constant out in front, I take the derivative, and I multiply it by that constant. We're gonna skip that dump. What we're gonna do is take that exponent, move it in front, and multiply it by the number in front, then reduce the exponent by 1. I'll show you. Now, you could approach this by saying, okay, I'm going to take the derivative of x squared to get 2x, then I'm going to multiply 2x by 3. No, I'm going to bring the 2 down, multiply it by 3 to get 6, reduce 2 by 1 to get 1, and 6x, I'm done. Notice what happens to the degree of the equation when you take the derivative. What does happen? It goes down. Okay. So we went from a quadratic to a linear. What's the derivative of 6x?
0. No.
0, 6.
It'd just be 6.
Just 6? Why? Liam?
Because you take that exponent down by
Because they said it and you just want to jump on the party bandwagon?
That's what we've done in physics.
Okay.
I believe it.
That's what we did in physics. Okay, like a lemming, just following rules. Liam, don't let the man tell you what to do. Bust out of your shackles, buddy. Live your life. Why is it 6?
Because if you take the exponent, x is 1,
Uh-huh.
you subtract 1, it's 0, and
Uh-huh.
0 is 0 times 1, so
Uh-huh.
it's 26 times 1.
Fantastic.
Yeah.
Nicely done, Andy. Liam, is that better, or do you just want to do what the man tells you?
No, I was tired. I don't know how to explain.
Okay, good. One over x is x to the negative 1. Bring it down, reduce it by 1. Bam! Okay. This will take 2 seconds. The derivative of a sum is the sum of the derivatives. The derivative of a difference is the difference of the derivatives. Just do the individual parts and add and subtract them like you had to start. There it is in fancy schmancy talk. What's the matter, man? You want to go back? There?
Oh, no, I'm okay.
Okay. I'll mind my own business then. Okay, take the derivative.
This end.
Oh. Let's see if my homie Kush can help us out. Kush, what do you got for us?
3x squared minus 4.
Sorry, start over again, please.
3x squared minus 4.
Hot diggity. Why? Please do, because I'm confused. I'm not the sharpest tool in the shed, if you know what I'm saying.
Took the 3, brought to the front, subtracted it by 1,
I'm with you.
then took the 1 on top of the x,
Yep.
brought it to the front.
Abby, explain that. Good, I'm with you.
One less
Where'd the
one.
5 go?
The 5, it went away.
That's my fault. I didn't ask the right question. Let me rephrase this.
It was x
Kush,
is-
what's the derivative of 5?
It was x to the 0 power, so then 0 times 5 is 0.
I don't dislike it. Good. Or it's a constant, and the derivative of a constant is 0. Well done. Thank you. Remember, if you take the derivative of a third degree equation, a cubic, you're going to get a quadratic. Oh boy, get you trigger finger. All right, try that one. Connor, you all good, buddy?
Yeah, I finished.
Thanks, buddy. You need a pass?
Yes.
Okay.
No, it's like this.
Nice job, Connor. Thanks.
You don't know how he did. Don't congratulate him. Maybe he screwed it up. Did you screw it up?
You made it.
You did amazing.
That was very No.
He's not silent, so it can't be that bad.
Yeah,
Yeah, I didn't love it, yeah. But we got to do this really fast. I mean,
You're welcome. Have a good weekend.
Okay.
What is the derivative? What is it?
well, that wasn't that test. After that test.
Yeah, the tangent. It's the slope of the
Sophie, let's hear from you. Okay, let's not.
Like where?
Okay, you let me know when it's convenient for you, okay?
This is your point? It's like the
I was being sarcastic. What do you got?
tangent. There.
What's the worst that can happen? You're wrong?
A point.
It's okay, we still love you.
You're finding the equation of the tangent line. If you want to find.
So close, you missed one small thing.
Multiple tangents.
There you go.
No.
Thank you, Haley.
That's
Appreciate the assist on that one. Yes. 4 times negative 1/2 is negative 2, reduce it by 1. 3 times 3 is 9, reduce it by 1, and the derivative of 2x.
But why is this why is it find v derivative? Hold on. What are you doing?
Okay, so, as we talked about, if you continue to understand that this derivative thing is finding the slope of the tangent line, then we can also find, and this is a common practice in here, where are those tangent lines horizontal? So the first question is, on a graph, what would a horizontal tangent line mean to the graph? What will happen at those points on the graph where the tangent line is horizontal? No. Yes, but what does it look like on the graph? Beautiful.
Oh, well, yeah.
Minimum or maximum? Peak or valley? So in this problem, what we're going to do then is find out where that quartic, 4th degree polynomial, has a peak or a valley. Okay? Go.
It is actually quite big. You can set the values between
Well, if you take this in, Oh, that's 0?
But
You just said
He's a 69.95.
you said I should have why don't you else?
I do too. You barely have an A, bro.
See what I'm saying? Like, it's yeah.
4%.
No.
Come on, bring it home.
Yeah, but are you gonna keep that for the rest of the semester? I want to see it.
there's an and.
Three sounds so good. Three sounds how many characteristics to You graduate early. Yeah, but you're graduating. Yeah, that's what I mean. Sorry.
Graduating from this one of my grades is actually graduating.
Yeah, I know one time we had to and I did I got it wrong. But college is so nice. It's so hard to back it on Oh wait, did you have you didn't have that? Okay, no, actually
I don't really think it's English.
I'm an adult and they're used to things that adults
Wait,
don't.
is it English for all 4 years?
Just wear sweatpants. Don't ask you. But like, it's like not that big of a deal. From like 25 yeah, no one asks me that serious. Oh, it's
That's fine. That's literally just a presentation. You gotta go. Did you ever try? Did you ever try? You gotta do this Oh.
All of them are good.
Say it like you say phone.
Like a fictional, like a fictional.
sorry,
I don't know what the fuck that crime means.
What's the derivative?
Okay, so let's come back together and talk about this. There are two components to this problem. Number one is understanding what we're doing. I'll come to that in a second. Number two is doing it. Okay? So we're talking about a tangent line, and as soon as you see tangent line, that's pretty much an indicator you're going to take a derivative. Yes? Brooke, what's a derivative?
4x cubed minus 12x.
Outstanding. Oh, there's my picture. I don't want to click because I think I got too much up there. Okay, so once we have the derivative represents the slope of the tangent line anywhere on the graph. It just depends on where you are. And we want to figure out where it's horizontal. So what's true about the slope of the tangent line when it's horizontal? It equals 0. Beautiful. So take that derivative and set it equal to 0. The derivative is a cubic. Basic law of algebra, you've got to have the same number of solutions as the degree of the equation. And if you look at the picture will tell you, yep, we need 3 answers. We have 1 peak and 2 valleys. Oh, man. Oh, I didn't do it. Okay. I can help. I'm pretty smart. Brooke, give me that again. F prime of x is equal to.
4x cubed minus 12x.
Does everybody agree? Hot diggity. What am I setting that equal to?
0.
0. Solve. X equals 0. You bet. It's right there. And x equals plus or minus the square root of 3. Which is over here. And over here. That's about your 1.7. We're good to go. There are a whole bunch of different, there are an infinite number of tangent lines. I could draw a tangent line over here. Let's say at 2.5. I could calculate the slope of that by plugging it into the derivative, but we're going to focus in this problem only on when the tangent line is horizontal, because we want to be able to find those maxes and mins, those peaks and valleys, those turning points, if you will. This becomes a major chunk of our work. Questions? Does that make sense? Okay, so I incorporated the mechanics with the theory in there of what we're doing. This is no explanation, it's just weird. When you take the derivative of e to the x, it's its own derivative, which makes no sense whatsoever, but we don't care, because it's really easy then. If I ask you to take the derivative of e to the x, you're going to get e to the x. Yeah, I know, I said the same thing. What? What?
What is the
What is that? What?
What's the reason?
Oh, we'll get there.
Okay.
Yeah, we got to crawl before we walk. Okay. You'll have this is a slide of faith, if you will. You're going to have to trust me on this one, okay? Because we don't have the math to explain why that happens yet, but we will soon. Oh, it's turned blue.
Freshman now.
Now, wait, hold on, let's back up. You know it's not going to be that easy, right? We're going to make it a little bit more complicated for this guy. So, what does f prime of x mean? The derivative of? Of f of x. What do you think f double prime means, Allie? Outstanding. And what do you think f triple prime means? Okay, and I'm assuming you're pretty good at pattern recognition, so I don't have to do that again. Okay, good. I was over there talking to my friend Posey, and she was taking the derivative of that last quartic, and then she took the derivative again and said, well, just keep taking the derivative. If you have a polynomial, let's go back to that problem. What happens if I just keep taking the derivative of that bad boy? Where will I end up eventually? 0. Good. Because it'll go from a 4th degree to a 3rd degree, 3rd degree to a 2nd degree, 2nd to 1st, 1st to 0. Done. 0. But guess what's not going to happen with this bad boy? It will not go to 0. So, Daniel, what's f prime of x? Nathan, he's got a brain, let him use it. He's not a trained puppy where you just show him how to get out of the house. Let him figure it out himself before he wets on the carpet.
Yeah, that was like a
I gotta work on that one.
That would be just 3xe to the x minus 1.
Say that again, you said it backwards.
3e x
To the x, yeah.
x minus 1
Outstanding.
minus,
Oh, what did it?
no, because you reduce the
3e to the x minus 1. We're all good, yes? Okay, good. Daniel, let me write that down for you, just in case you're a visual learner. So you told me that f prime of x was 3e to the x minus 1.
Yeah.
And everybody agrees, yes? Yeah? 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 Okay, all right. Back to you, Daniel. What's f double prime of x?
Plus 3ex.
Yes?
Yes.
Yeah.
Outstanding. Are you feeling saucy?
Sure.
Yeah. Daniel, what's f triple prime of x?
Same thing as above.
Oh. You sure?
Pretty sure.
Okay, you ready? This will be the culmination. Dot, 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 f 27th prime of x. Same thing. Good. That idea of getting to a repetition will not happen with plain old polynomials because, like I said, the degree drops every time. However, when we get weird things like e to the x, and then, of course, at some point, we're going to start talking about your friend and mine, Mr. Trigonometry, we get weirdness like this. Yeah, I know, but that's nothing to worry about now, kids. It's its own derivative. Later on, however, we're going to look at some fun stuff like, what if it's not just e to the x? What if it's something crazy like e to the sine of x? Oh, that's going to be fun. Yeah, but not now. It's way too early for that. We're just working on the basic power. We're done. Questions? Beautiful. Okay, do this. No. And hi, come on in. Wait, hold on. Come on in. Let me finish recording.